Okay, so let's continue using our little hidden ball trick, if you would. So here again, the middle term, we're going to let x to the -1 equal my new variable a. If I square both sides, we end up getting that a squared is equal to x to the -2, right? We're multiplying exponents there. So this means that that is going to be replaced with a squared, that's going to be replaced with a, and there's our hidden quadratic in terms of a. So solving this, let's see, I believe we're going to have a 1 and a 3, I believe a 4 and an a. And I think, let's see, is that going to get the trick done? No, as a matter of fact, so that's my guess and check. So let's go back here. I think 2a and 2a equals 0. We need a 3, we need a 1. I believe that will get the trick done, right? So first times first is first, last times last is last. -2a, positive 6a, yep, so there we have it. So that now means that 2a minus 1 is 0, or 2a plus 3 is 0, right? Adding 1 and dividing by 2, we get a is equal to 1/2. Subtracting 3 and dividing by 2, we get a equals -3/2. So there's my solution in the a world. So walking it back, well, we're going to come back to here, and how about to help ourselves out? This is just 1 over x squared, and this is 1 over x. We're coming back here. So if a is equal to 1 over x, this means that 1 over x is equal to 1/2, or 1 over x is equal to -3/2. And so we can do a quick cross multiplication. We get that 2 is equal to x for that route, and a quick cross multiplication here, right? That should be an x. We end up with -3x equals 2. Divide by -3, and there's our answer. So -2/3 and 2, right, are our two answers for that guy. So took advantage of the fact that we have a fraction equal to a fraction. I can just cross multiply. So again, those should check out. We'll take a look at those when we actually do some work with the calculators later. But right now, there's the solution. Here, the middle term from the couple of videos ago, we're going to let a equal 1 over x plus 2, which meant that a squared was 1 over x plus 2 squared. So this piece is a squared minus this piece, which is a, minus this piece, right, minus 6 is equal to 0. Have a quadratic. Factoring this, we end up with that as our factorization. So a minus 3 is 0, or a plus 2 is 0. Adding 3, we get that answer. Subtracting 2, we get that answer. So there's our solution in the a world. But I got to walk it back, right? So come back up to here. So if a is 3, that means that 1 over x plus 2 is 3. If a is -2, that means 1 over x plus 2 is -2. So I'm just using this as a two-way street to start and to walk it back. Again, over here, what I have is a fraction equal to a fraction, so I can cross multiply. Under the first case, 1 times 1 is 1, and 3 times x plus 2. In the second case, we have 1 times 1 is 1, -2 times x plus 2. And so we just have some equations to solve. So 3x plus 6, subtract 6, we get 3x equals -5, divide by 3, we get -5/3 is one of our answers. Okay, over here we get 1 equals -2x minus 4, add 4 to both sides, and we get 5 equals -2x, divide by -2, and we get x equals -5/2 as one of our answers. So there's the solution of this equation in the x world. So we get there by making a substitution, get a quadratic, solve the quadratic, and then walk our story back using that same substitution. On and on and on. So I think in a couple of videos ago we found that this term, right, we're going to let a equal x to the 1/4, which means that a squared was x to the 1/2. So this is now a squared, that's 7a minus 8 equals 0. And again, we're squaring both sides here. And if I square this, I multiply by a half, or by 2, which gives us 2/4, which is a half. Factoring, I believe this will create that. Okay, so a plus 8 is 0, or a minus 1 is 0. Subtracting 8, we get negative 8, and adding 1, we get 1. So there's our solution in the A world, but we have to walk it back. All right, so this means that x to the 1/4 is negative 8, and this means that x to the 1/4 is positive 1. This is a radical, so if I raise everything to the 4th power, right, we end up with x equals, gosh, negative 8 to the 4th power. That's huge. Whatever the heck that is, right? And I know that one is 1. The reason I'm saying whatever the heck this is I believe this is going to be extraneous anyways, all right, if you double check that. So I'm pretty sure 1's going to work. And whatever, if you wanted to finish that off, definitely breaking out a calculator at that point, whatever number that is. But I think it's extraneous, and I'll let you double check that if you find it and kind of take a look at it. Alrighty, so again, there's our hidden ball trick, if you would. Again, I'm taking advantage of what's the middle term, squaring it, getting the front term. That sets up the substitution. You make the substitution, solve the quadratic. Right now, everything factors real nice. And then we walk our story back using our substitution. So one more time. Over here, here's the middle term. So we're going to let x to the 1/3 be my a. If I squared both sides, we end up with a squared equaling x to the 2/3. So we have 3a squared plus 5 times a minus 2 is equal to 0. Factoring, again, I'm pretty sure everything factors. Let's see, yeah, 2, 1, and I believe this needs to be positive and negative. All right, so I think that gets the job done. So 3a minus 1 is 0, or a plus 2 is 0. Subtracting 2, we get negative 2. Adding 1 and dividing by 3, we get 1/3. So there's my solution in the A world, but let's go use our substitution to walk that back. So if a is 1/3, this means x to the 1/3 is 1/3. This would say that x to the 1/3 is negative 2. Since this is a cubed root, we're going to raise everything to the 3rd power. And over here we get 1 over 27. And over here we end up with negative 8. And I do believe that both of those do actually work. There's no extraneous solutions here. That, like I said, we'll double check with some technology next week. Alright, so there's your hidden ball trick, and that pretty much covers section 1.5. Like I said, I think each one of these could have had their own section standing alone, but our textbook decided to put them all together. This one's pretty much on steroids. If you're lucky, you can use another technique to solve it. Like we could have used our rational idea here. We could have used our radical idea up here. But there's basically the groundwork behind a hidden quadratic. Make sure it is a hidden quadratic. Use the substitution to your advantage, solve the quadratic, walk your story back, and that's how it typically happens. So that wraps up the module. Practice. If you need help, please jump on Canvas, ask questions there, or you can request a Google Meet time where you and I can maybe talk one-on-one, and you can get a little bit more help and a little bit more assistance. So the help's out there. You just need to reach out for it in the new mode of instruction that we've got. All right, good luck to you guys. Get in that homework, and I'll talk to you guys later.